Hello students, so in this lecture we shall be discussing about the process of recovery, recrystallization and grain growth take place in a crystal. Now all these processes are subject to a change in temperature of the crystal being subject to a change or rather an increase in temperature. It is also called or a systematic increase in temperature, which is also known as annealing. Main purpose of annealing has always been to relieve the amount of stress and to assist crystallization. Now, whenever a crystal has or a material has been subject to some kind of stress, so there are dislocations generated inside that material, and these dislocations will have density. Now, when this material is subject to annealing, with respect to time, what has been found is that the dislocation density dies out, and the rate is faster if we increase the temperature. So temperature is in this direction, so there is a decrease. Slower is the temperature, the more time will it take to ease off the stress and to decrease the dislocation density. And so you can represent, this is an Arrhenius type of equation, and we can represent this nature by this formulation 1 by tau, which represents the time, A equals exponential minus activation energy Q by RT. Now the temperature at which the change of stress or the maximum dislocation density or the recovery process, so-called recovery process, starts to take place, where there is an annihilation of dislocation, or the dislocation dies out. So this is also known as annihilation. And this annihilation is caused by temperature increase in temperature, which provides mobility to the dislocation. And the temperature usually at which this process initiates is more than 1/3 of the melting temperature. So from this temperature onwards, the process of recovery takes place in the material. Now, during recovery, what happens is a process of polygonization. So the polygonization means that there is a formation of grains, a formation of regions with different orientations. Now, what do we mean by this? So let us say when a crystal has been stressed, so it has got a lot of dislocations. So in the initial state, when no temperature has been applied, we can say that we can represent the crystal by in the form of a bent lattice, and we can assume that there are dislocations in the lattice. However, the dislocations may not are either in one direction or they are in the opposite direction. Now, when we increase the temperature, so what happens is that the grains they start to annihilate. That means positive and negative grains, they come together and they dissolve. So we are left with a fair number of dislocations. Like say this one, the dislocation density has reduced considerably. Now these dislocations, what do next they do is they localize the lattice curvature into polygonal regions. Lattice curvature into polygonal regions. That means the lattice takes the form like this. So they end up into different polygonal zones, and this is how they go into this state. So initially there is a reduction of energy, so if you consider as the initial state with some number of dislocations, like dislocations, so energy is proportional to mu v square. While after this localization take place, that means the dislocations come together and they start to form stub grains, so they align themselves, then the energy, which is the final, is mu v square by 2. Now, looking into the grain growth, what happens in the grain growth is if this suppose is initial grain structure, and on which these are the new grain formations start to take place. So these nucleus formation takes place at multiple places, and they start to grow, and that time comes when the original crystal structure is lost and these new grains form the new crystal structure. So there is nucleation and growth of new free regions. The original architecture is lost. So this recrystallization is again based upon a theory called J-Mac theory. Where JMAC stands for three different scientists who made this theory. J stands for Johnson, M stands for Merck, E stands for Avrami, and K stands for Kolmogorov. Now this theory tells that the impingement flux, or say if you plot fraction of crystallization, F is the fraction of crystallization with respect to time, you get a plot made like this. This change in curvature here, so there is initial of nucleation. This is the first change in curvature, and this change in curvature where it starts to get saturated is the growth process taking place. And here what happens is that the grains start to coalesce, so that is called impingement process. That means the two grains now come in contact with each other and they start to grow. Okay. And the equation starts, if you draw tangent at this time t is equal to 0, the equation process starts to take place. Now this impingement, based upon this impingement, we have something called an impingement flux. According to which the dF change in the fraction of crystallization is equal to dF x into 1 minus f.